physical states of matter are something that you probably are already familiar with. In fact, when we look at this picture here of a hot air balloon floating over a lake, and the lake has some hills around it, we see all of the physical states of matter present. In the lake, we have liquid. We have liquid water. Oops, if I have my thing. Well, let's make it not pointing at the bush. There's my liquid. And in the hot air balloon, inside, we have gas, we have hot air, and the hills are solids. So you may have heard the term gas, liquid, or solid before this, and you may have even, obviously, encountered them in your real life. Let's talk about what they look like on a molecular scale. I'm going to get rid of my little deal there. What you can see from this image is that solid particles, or the particles within a solid, are packed very close together. And they are very organized in most cases. Depends on my crystalline structure, but for this part of our conversation, we can say they're very organized. They're very close together, they're very tightly packed, and they don't have a lot of space in between them. On the other hand, when we get to the liquid, we can see that now I've got some spaces. It's not as organized. It's not as tightly packed together. I've got a little bit more space in between my particles, a little more freedom to move around. When I get to a gas, now we have lots of empty space. Lots of regions where there aren't particles, and particles are very separated from one another. So we can talk about solids and liquids and gases in terms of, hey, the particles are very close in a gas. And because they're very close, that impacts the way that solids behave. In liquids, we have particles that are not as close together as a solid, but more close together than a gas. So this is sort of the middle ground. And then gases where there's lots of empty space in between our particles. So particles are very spread out. That leads to some observations that we use to define what's a solid, what's a liquid, and what's a gas. So the characteristics that we look at here are shape and volume. So what does this thing do? Does it keep its own shape when we put it in a container, or does it take the shape of the container? If it keeps its own shape, then we say it has a defined shape or a definite shape. And solids are an example of a substance that has a defined shape. When you take, for instance, a penny, a coin, and you put it in your pocket or you put it on the table, it keeps its own shape regardless of which container it's present in. The volume of that coin is going to stay the same as well, regardless of whether you squeeze it really hard or try and pull on it. It pretty much just stays a solid. And it stays the same, continues to take up the same amount of space. So it has what we call defined volume. A liquid, if you take some water and you pour it into a glass, and then you pour that glass, you turn it over, let's say, you turn it over, where does the liquid go? Well, it runs out to cover whatever surface you've dumped it on, because it's out of your original container, and now it's taking the shape of the new container. So another way to think of it is if you had a round sort of circular glass versus a square glass, and you poured your water from your liquid from your circle glass to your square glass, you go from having the maybe cylindrical shape volume to having a more cubical one. So we say that liquids have indefinite shape and that they take the shape of their container. The volume of a liquid doesn't change a whole heck of a lot. So we say that it also has a defined volume, just like a solid. Gases, on the other hand, both take the shape of their container. And you can think of, like for instance, a can of some kind of carbonated soda, like Coca-Cola or Pepsi or something like that. When the can is unopened, the gas is trapped inside and is taking the shape of the empty space in the can. When you open it and you pour that soda out into a glass, what does the gas do? Well, it takes the shape of its new container, which is actually open to the atmosphere because there's no lid on the glass. So your gas bubbles out and expands. So the gas both does not take the shape, it does take the shape of its container, it also is both expandable and compressible. So gases have indefinite shape, and they also have indefinite volume, because we can compress and expand them. And that comes from the characteristic of gases that they have a lot of distance separating their particles.